So the next section, we're looking at adding and subtracting rational expressions, and we're going to start by looking at what happens with fractions. Now, if I have 5/12 minus 3/12, I already have a common denominator, so we know that we can just go ahead and subtract the numerators. We're going to get 5 minus 3 is 2/12, keep the common denominator, and then just reduce it to get your final answer. Divide both by 2, you get 1/6. Okay, so if I already have a common denominator, all I need to do is add or subtract the numerators and keep that same common denominator. So let's look at a couple of examples where that's the case. In this first one, I already have a common denominator. My common denominator is x. I'm going to add the numerators just by combining like terms. So 5x doesn't have a like term, so I'm going to keep the 5x plus 6. 2 plus 4 is 6 over my common denominator of x. Check to see if this can be reduced. Since my binomial can't be factored, I know this cannot be reduced. Let's look at the next one. This one's a subtraction. 9x minus 5x. I already have a common denominator, so it's going to be 4x over x minus 3. This also cannot be reduced because my binomial cannot be factored. In part C, I have a common denominator already, so when I add up the top, I'm going to get c squared. Negative 5 plus 3 is negative 2c plus a negative 24, so minus 24, over the common denominator of c squared minus 16. I don't know yet whether or not that can be reduced, so I need to factor. We're going to factor that into c in the first two, and that's a 24. So if we do a negative 6 and a positive 4, that'll add negative 2. The bottom is a difference of squares, so it's going to be c plus 4, c minus 4. Oops, c plus 4 and c minus 4. Alright, and this does reduce because I got a c plus 4 on both. I'm going to divide that out, and I'm going to be left with c minus 6 over c minus 4. Okay, and in the next one, in the subtraction, something I have to really pay attention to is that I'm subtracting this entire polynomial. So the subtraction is going to apply to both parts of this numerator. I need to distribute it. So in a subtraction problem, I would really encourage you to rewrite this as x squared plus 9x minus 4x minus 14. Rewrite it with that subtraction distributed, then start combining your like terms, just so we don't have any negative errors or sign errors or losing that subtraction. Okay, so this is going to be x squared plus 5x minus 14 over x plus 7. And my warning right here is, again, when I'm subtracting rational expressions, be sure to subtract the entire numerator, and that means distribute. Alright, let's check to see if this one can be simplified. I need to factor it. So I ran out of room. I'm just going to come down here. And let's see, the top one is going to factor into, it's 14, so 7 and 2. I need that to be a positive 5, so it must be a positive 7 and negative 2 over x plus 7. The x plus 7s will divide out, so the answer to this one is x minus 2. So in those last couple of examples, there were problems that already had a common denominator, but we know that's usually not the case. Usually we need to find ourselves a least common denominator. Okay, so that's what we're going to look at doing. Now the process for finding the least common denominator is going to be to factor each denominator completely, then just list the factors of the first denominator, and then add to it any factors that the second denominator has that didn't appear in the first list. Okay, the common denominator is going to be the product of all of those factors. So let's see how that works with 40 and 50. If you're familiar with using 40 and 50, you might know that the common denominator is 200. And let's see how we can get that using this process. Okay, so first of all, I need to list the factors of each denominator. 40 is 4 times 10. But those aren't primes yet. They're not fully factored, so I'm going to keep going. 4 is 2 times 2. And 10 is 2 times 5. Okay. 50 is 5 times 10. Alright, so 5 is prime, but I can rewrite 10 as 2 times 5. So to get my common denominator out of this list, we're going to write down the first denominator, so 2 times 2 times 2 times 5, and then compare that with the second denominator. The second denominator has a 5, good. Has a 2, good. But has a second 5 that wasn't already in that list. So we need a second 5 here. Okay? So the least common denominator is this product. So 2 times 2 times 2 times 5 times 5. That's 200. Alright, now that's the same process that we're going to use while we're looking at our polynomial denominators. So, to start with, I need everything completely factored. X plus 4 is already factored, but I could take a 3 out of the other one to make it 3 times x plus 4. So my common denominator says list an entire denominator. It doesn't really matter if I list the first one first or the second one first. Just to show, I'm going to list the second one first. 3 times x plus 4. Now this one right here already has an x plus 4, so we're good. Okay, so that 3 times x plus 4 is the common denominator. So what I need to do next is to write each fraction with that common denominator. So I'm going to start by writing each fraction down. So 8 times x plus 4 minus 7 over 3 times x plus 4. Alright, now I need to look at my common denominator and see what I'm missing. This one right here is all set. It already has the entire denominator, but this one is missing a 3, so we're going to multiply it by 3 on top and bottom. Okay, that's going to give us 3 times 8 is 24 over 3 times x plus 4 minus 7 over 3 times x plus 4. Now that I have a common denominator, we're going to finish that subtraction, and we get 24 minus 7 is 17 over, I was going to write it right here, 17 over 3x plus 4. Okay, so that's my final answer. I can't reduce 17 and 3, so I'm done. Okay, so let's try again in the next one. I need a common denominator. My common denominator is going to start by listing the first denominator. The first denominator is x plus 1. Then listing the second denominator. The second denominator doesn't have anything in common with the first denominator, so I need the entire thing. X minus 1. Okay? So, the first fraction is x times x plus 1. That needs the x minus 1 on top and bottom to have the common denominator. The second fraction is 3 over x minus 1. That fraction needs the x plus 1 on top and bottom to have the common denominator. Okay. Now, since I do need to add up, Since I do need to add up the tops, I do need to distribute the tops. I do not distribute the bottoms because they're already the same. They're common. So this is going to be x squared minus x over x plus 1, x minus 1 plus 3x plus 3 over x plus 1, x minus 1. Okay, add it all up. The top is going to be x squared plus 2x plus 3 over x plus 1, x minus 1. And I'm not done yet because I think that top can be factored. So the top is going to factor into x plus 3. Let's try x minus 1. That doesn't work because that would make a negative 3 right there. So, no, I was thinking wrong there. That doesn't factor, but it's good to try. Okay, that top doesn't factor. I need that to be a positive 3 and a positive 2, so that doesn't factor. So this is my final answer. Okay, that's an x squared plus 2x plus 3 over x plus 1, x minus 1. Alright, I'm going to have a little bit more space on these, which is good. Need a little bit more space. Okay, so I don't know what the common denominator is until I factor, so let's factor this one. X plus 3, so I'm going to need minus 3 and minus 1. And x plus 3, x minus 3 for this one. So my least common denominator is the first denominator, x plus 3 times x minus 1, times, I already have an x minus 3, but I need an x plus 3. Okay, so I should be able to cover up part of the first, or part of the, any denominator. I should be able to cover up this part to see the first one, and this part to see the second one. So I have both denominators encapsulated inside this least common denominator. Alright, so the first fraction really is 2x over x minus 3, x minus 1. That fraction needs an x plus 3 on top and bottom to make the denominators the same. The next fraction really is a 4 over x plus 3x minus 3. And that fraction needs an x minus 1 on top and bottom to have the common denominator. Okay. Again, I'm going to distribute the tops. I need to distribute the tops so that I can figure out what my like terms are. But I'm going to leave the bottoms as they are because they're already common. Okay. So we've got 2x squared plus 6x over x minus 3, x minus 1, x plus 3, plus 4x minus 4 over x plus 3, x minus 3, x minus 1. Okay, so the denominators are the same. So now we're going to add it up. 2x squared plus 10x minus 4 over x minus 3, x minus 1, x plus 3. Okay, it can be factored. I can see that there's a 2 I can take out of the top. So let's take that 2 out. We're going to be left with 2 times x squared plus 5x minus 2 over x minus 3 times x minus 1 times x plus 3. Let's see, trinomial can be broken down some more. 2, 1 positive and 1 negative, so there's only one way to make a 2. It's a 2 and a 1, and those will add up to a 1 or negative 1, so I can't make the 5. So we're done. Okay, and let's try the next one. Okay, we want to start by factoring. So if I factor the bottom, I'm going to take a 2 out. It's going to leave me with 2 times x plus 2. The bottom of the next one can have an x taken out, so that's x times x plus 2. So the least common denominator is 2 times x plus 2, but I also need that x. So let's make it 2x times x plus 2. Alright, so the first one was x over 2x plus 2. To get the common denominator, I need to multiply by x on top and bottom, minus 2 over x times x plus 2. And to get the common denominator, I need to multiply by 2 on top and bottom. That gives me x squared over 2x times x plus 2 minus 4 over 2x times x plus 2. So my subtraction is going to be x squared minus 4 over 2x times x plus 2. The top can be factored, the difference is squares. that'll be x plus